Uh, I'm going to start on this one. It's the last one that we left off yesterday. I'm going to do it again one more time. It says, Elena needs to cut a square piece of wood with an area of 140 inches. How long will the sides of the square be, rounded to the nearest tenth of an inch? So once again, what kind of figure are they talking about? Square. So the first thing you do is draw a square. Label the area inside 140, and this is inches squared. So they want to find out what the sides measure. To find the area of a square, what do? We multiply side times side, and all these sides measure the same. Is that correct? Yes. That means a number times itself to give us this. And how do we find that? Well, by taking the square root of 140. So, once again, yesterday I saw some of you a little bit hesitant on this one. On this one, we got to start thinking perfect square numbers. What is my first perfect square number? 1, because it's 1 times 1. The next one is 4, because that's 2 times 2. The next one is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and I'll stop right there. So between what two perfect square numbers does this one fall? 121 and 144. So I write 121 and 144. So this is saying to take the square root. So what is square root of 121? 11. Bless you. Square root of 144 is 12. So if this one is in between these two, therefore my decimal form is going to be between 11 and 12. That's why this one is approximately 11 point something. So to find that something is coming up with a fraction. So let's see. 140, take away 121, that leaves me with 19. And then we do 144, take away 121, that leaves me with 23, Michael Jordan. So let's do the long division on that one. We got 19 divided by 23. Does not fit in there. Add a 0. Fits in there 8 times? Mm-hmm. Yes? Mm-hmm. 8. 8 times 3, that's 24. We got 2. 8 times 2 is 16 plus 2, that's 18. Subtract, that's 6. Add a 0, bring it down. If it's in there twice, that's 46. Subtract, that's 14. Bless you. 140. How many times does that fit in there? 6? Is it 6? Okay, let's try 6. That's 18. I got 1. That's 12 plus 1. That's 3. And that leaves me with 2 left over. And I'll stop right there because it says here to the nearest what? 10. So 10th is this one. This is 100. So let's see. This becomes 3. So this one stays a what? An 8. So therefore, each side, it says, how long should the sides be? 11.8 inches. No, that's for area. The length is just that. Nice. So let's go to the next one. That was number, what number was that? 5. Let's go to number 6. Now look at this one. This one is very similar, except for it has an extra step at the end. So it says, a square room has a tiled floor of 169 tiles. So what figure are we going to draw? A square. And it has a squared tile floor of 169 tiles. 169. So in here there's 169. And it's a square. That means a number times itself, that gives me 169. How do we find that? By finding the square root. Is that correct? All right, so what is the square root of 169? 13. So that means that the side measures 13. Is that correct? Now look at this. Be careful with this because this one, some of you just gave me an answer of 13. But look what it says. How many tiles are along the edge of the room? Here's one edge. Here's another edge. Here's another edge. And here's another edge. What do I need to do at the end? Add 4 sides or multiply 13 times what? 4. Times 4. So we multiply times 4. That becomes 12. I got 1, 4, 5. So it's 52 tiles. And that's something that some of you forget to do. Everybody see that? Okay. Let's do one more of these. Do this one by yourself. There it is. It says, a square room has a tile floor that with 144 square tiles. How many tiles are along the edge of the room? Copy that and solve. Go. Okay, what'd you get for this one, Gabriel?
48 tiles.
48 tiles. Hands if you agree with that. That is correct. So once again, you drew your square. We know that this is 144 tiles in here, but they want the sides, and we said this is a square, so that means we take the square root of 144, which is 12. And if there are 12 tiles on each side, all we have to do is multiply 12 times 4, or add 12, 12, 12, 12, and that gives us 48. All right, let's move on. Let's go to the next one. What number is this? Number 6? Number 7. So, look up, please. I'm going to zoom in. It says, what are the possible values for x? And careful with this one, because this one, some of you just did something very simple, and you got half points. Here we go. Look up. We said, in order to solve for x, to cancel this squared, we need to take the square root of each side. Are we there so far? Yeah. However, let me ask you this. What number times itself, because now it's an x value inside of the radical, gives me 36? X equals 6 times 6, or x equals negative 6 times negative 6? Because both give me what? 36. So the correct answer for this one is x equals plus minus 6. And so you got that by yourself. Okay? All right, let's do another one. Copy this one. Oh, it doesn't have, I'll give you another one. Here we go. X squared equals 81. All right. What'd you get for this one, Naila?
X equals plus minus 9.
X equals plus minus 9. Hands, have you got that? That is correct, once again, because in order to cancel this square, we take the square root of each side, and that's how we get this. Okay, let's move on. Number 8. All right. Look at this one. Very similar to the one we just did. Look up, please. Except for this one has the power of what? 3. So now check this out. To cancel this, we take the cube root, and it's written like that. Cube root of this and cube root of this. That means this cancels this. We're left with x equals. Now this one, look, what number times itself 3 times gives me 8? 2 times 2 times 2, so the answer is 2. Could it be negative 2? No. Let's find out why not negative 2. Negative 2 times negative 2 times negative 2. 2 times 2 times 2 is 8. But what is negative times a negative? And times a negative? Is this a negative? No, that's why it's not on the negative side. So this one, the correct answer is 2. Let's do another one of these. Example, we're on number 8, is it?
9 now.
Is it 9, the same one?
No, 9 is the number one.
So this is 8?
Yes. No, you just say. Yeah,
Oh my goodness. 8 cubed. Solve this one, please. Example 8q. X cubed equals, okay, 64. Go. Copy that. Do that by yourself. Focus, please. All right. Check with the neighbor, see what they got. All right, here we go. So to cancel this cube, we take the cube root. Cube root. This cancels this. We got x equals. What number times itself 3 times give us 64? Yes? 4. 4 times 4 is 16 times 4, 24. I got 2. 4 plus 2, that's 6. That is correct. Hands if how you feel with these. 1 being the lowest, 5 being the highest. Okay. Okay, let's do one last one. Here we go. Let's do 8 super cube. X cubed equals 27. Don't say it out loud. Keep it to yourself. Let people think. Let's see. Natalia, what'd you get? X equals 3. Hands if you got that. That is correct. Let's move on. Let's go to number 9. Number 9. All right, it says, on a number line, subtract negative 1 1/3 minus 1 1/2. Okay? So, get a number line going. And let's see. We're going to start with 0. So, look up, please. Let's start with the first number that they give us. The first number is negative 1 1/3. That means we're going to the left. How many steps? 1 1/3. So here I'm going to label this. This is 1, 2, negative 1, negative 2, negative 3. Okay. So 1 1/3. So 1 step this way is there, but then 1/3 more. So if I divide this into 3s, then 1/3 more is right there. So I'm at negative 1 1/3. Are we there so far? Okay. But then they ask us to do the next step, which is what? Negative 1 1/2. Now, how many? This is a negative. We're still going to the what? To the left. So from here, we're going to go to the left 1/2 and 1. So before I do the 1/2, let me do one step the other way. So right now I'm at negative 1 and 1/3. If I take one full step this way, where am I going to land?
2 and 1/3. Negative 2 and 1/3.
Negative 2 and 1/3. So if I take one full step this way, I should be at negative 2 and 1/3. Does everybody see what I'm doing?
Yeah.
But we need now what? A half a step. Are we there?
Yeah.
Now, since we are dealing with thirds, we don't know what a half step is in regards to thirds unless we change it. So therefore, we need a common what? Denominator. So therefore, we got 1/3 and 1/2. What's our common denominator? 6. So this would be 6 and 6. So this is 2 and this is 3. So therefore, 1/2 step is how many sixes? 3 sixes. So watch. So here, is everybody following what I'm doing?
Yeah.
All right, so I'm going to divide this into 6. So this is 1/3 and 1/3. But now I'm going to split this one here, here, and here. So now let's see. 1, 2, 3, 4, 5, 6. Now we have sixes. So from here, right now I'm at,
Negative 2 and 1/3.
let's see, 1, 2, 3, 4, 5, 6. So I'm going to use this one as my negative 2 and 1/3. Hold on. I'm going to use this one. All right. So I'm right there, and I need to take 3 sixes that way. So from here I go 1, 2, 3. Where do I land, guys? Where am I at?
2 and 1/6. Negative 2 and 1.
Now these are sixes, right?
Yes.
We got 1, 2, 3, 4,
5.
5. So I'm at what? Negative 2 and
Oh, 5.
5 sixes.
I got that.
Yeah? You nice? So just be careful that at the end you need to divide this into what the common denominator is for both fractions. Okay? Want to try one more?
Yes, please. Yes, please.
Yes? Okay, let's do one more. Example, this is 9Q. 9Q. Example 9Q. Let's show on the number line negative 2 and 1/4 and negative 1 and 1/2. I'll give you some time to do that one, and then I'll go over it together with you. See how you do by yourself. Go. Omar, focus. All right, so if you need more time. Okay, I think we got it. Let's see. I'm going to get my number line. And then I got 0, 1, 2, 3, 4. These are all negative. All right, let's see. This one tells me to go to the left. How many steps? 2 and 1/4. So I go 1, 2, and 1/4. That means I need to divide this into fourths, yes? 1, 2, 3. Now it's in fourths. So 1/4 is about right there. So this is 2 and 1/4. All right. But then the second time, it tells us to go one full step and a half a step. So if I take a full step this way, where am I going to land? 3 1/4. 3 1/4, and it's a negative. All right. So let me divide that into fours. What's that? All right. So I'm at 3 1/4. But I'm still missing that half a step, yes? So in order to know how many fourths I need to take, I need to change these. So let's see, I got 1/4 and 1/2. What's our common denominator? 4. So this is 1/4, and this is 4. This becomes 2/4. So from here, I'm going to take 2 more steps on the 4th. So here I go. 1, 2, and where do I land? Negative 3 and 3/4. Hands, have you got that? It doesn't matter, right? Did everybody hear the comment? Jocelyn said, it doesn't matter when I do the common denominator as long as I do the common denominator so I can do that step at the end. One more time, or are we good? Show me with your fingers how comfortable you are with these. I got some 3s, 4s, 4 1/2, 5s. Some of you need manicures already. All right, let's move on. Go to number 10. Number 10. It says, look up, write all names that apply to the number 5/7. 5/7. Okay, start with a very obvious one, which is what? Okay, I'll go with fraction. All right, that's the most obvious one. Another word for fraction, we said, is called a rational. Rational. So within, and let me remind let me get your noodle going. I remember when we did real numbers. Remember when we did real numbers? Yeah. Yes.
Yes.
Yes, Carly.
Is an improper fraction still rational?
Yes. All right, so remember when we did real numbers?
Yes.
In real numbers, there's 2 types of numbers. There are rational and irrational. Remember that?
Yeah.
So since this one falls in here, but it's also part of what? So this is also a real number. Ever see that? Okay. All right, so those are the 3 names for that. Let me give you another one. Example, this is 10Q. Get it? 10Q?
Get it.
All right. Here we go. Look up, please. Number 23. 23, Michael Jordan. Give me the names for that number. Different names for that number. Go. What?
Never mind.
All right, check with the neighbor, see what kind of names he got for that. All right, let's see. Here goes different names. Well, the obvious one is what? Real number. It's also a rational. And let me show you why. A rational could be a what? Could we write this as a fraction? Yes, 23/1. It's also a rational. Also, this is also a integer. Are we there?
Yeah.
This is also a whole number. But this is also a...
What's the difference between whole number and real number?
Very good question. What's the difference between a whole number and a what?
Real number.
And a real number. Real number are all the numbers in here. But whole number is only a specific number. Let me show you that. Let me give you the last one. Last name for that one is counting number or natural number. Now let me review this because I see some of like a disturbance in the force. So when I introduced this, I said, check this out. Look up, please. I'm going to focus right now on all the numbers that fit in here. But I'm going to come out here so I can show you. And I said, the very first set of numbers that we learned when we were in mathematics, starting in preschool, were counting, or kindergarten, were counting numbers, remember? And I said, remember when you ran to the swings and you got there, I'll race you, ready? -1. No, you didn't start counting with negatives. You started counting with what? 1, 2, 3, right? So those are known as counting or natural.
So wouldn't every number be counted?
Most of the numbers, yes,
Except negatives.
except negatives. So those aren't counting numbers. But as soon as you got to a higher grade level, which they introduced, I think 0, they introduced it in second or third grade, they introduced the number 0. They're no longer called counting. They could be counting, but only from numbers 1 and on. But when it includes 0, these are called whole numbers. Are we there so far? From there, when you got to fourth grade and they started introducing negative numbers, such as -1, -2, -3, ... So basically the opposites of these, including 0, all of these are called integers. Are we there so far? And the next one, rational number, is any number that can be expressed as a fraction. Could all these be expressed like fractions? Yes. What others can be expressed like fractions? 0.25. Can we express 0.25 as a fraction? Yeah, it's 1 over 4, 1/4, right? And any other fraction, 3/4, 1/2, all those, including these, are known as what? Rational numbers. And of course, all of these are part of the what? Real number system. So what are irrationals? Irrationals are numbers that never end, such as square root of 5, square root of 2. Why? Because we can't find a perfect square root of that number, and when we do the decimal form, it keeps going. What other number keeps going? Pi. It never stops. So all those are irrational. Everybody remember now? Yes, Mr. Q. All right, let's move on. Number 11. Number 11. Okay, let's get to these. These, I heard some of you were still, you kind of forgot when we got to these. So the first thing we do, look up. Before I do this one, let me refresh in your memory. When we have 4 to the 5th power, that is 4 times 4 times 4 times 4 times 4. Yes? So that means 16 times 16 times 4. 16 times 16, 36. I got 3, 9, 1, 6, 256. That's 256, but then at the end times 4. So that gives me 24. We got 2, 22. We got 2, 8, 10, 1,024. So this is 1,024. Yes? However, look at what happens when the exponent is a negative. We no longer just write it like this. This becomes, you guys remember that? That in order to get rid of the negative exponent, we need to send it to the what? To the denominator. Remember that? Yes. All right, so let me show you another one. About 2 to the negative 4. This is the same as what? 1 over 2 to the positive 4. And, of course, this is 2 times 2 times 2 times 2, which is 1 over, this is 4 times 4, which is 16. Are we there so far? So now that we got that introduction, let's go back to the previous problem. Look at this one. How do we rewrite this? This becomes 1 over negative 3 to the what? Positive to third power. Therefore, how do we rewrite this? 1 over negative 3 times negative 3 times negative 3. And this becomes 1 over negative times a negative, positive times a negative, negative, and this is 27. Let's do another one of these. Guys, I see some of you not writing anything down, and this is part of your final. I'm just letting you know. All right, example, what is this one? 11? Yes. 11Q. Simplify. Parenthesis, negative 2, close parenthesis, to the negative 5th power. See how you do that one by yourself. Go. Check with the neighbor, see what they got. All right, let's see. Who got 1 over negative 2 to the 5th power, which is 1 over negative 32. And do we got that? Okay. I'll stop right there. Your home plate for tonight is to finish those 2 pages that I gave you for the study guide. And I'm going to have also you to bring back a signed progress. So I'm going to have Nailea, Carly, help me pass these out, please. Gabriel.